Okay, so here we are. We're on our final example for today. And this says, Mr. Jones counted the number of cars in the parking lot at each of the home sporting events. So we're talking about a school, obviously. And he counted the number of cars in the parking lot and he made a little chart. So the first thing that we're going to do is we are going to take this data and we are going to make just a very small list of what we're going to need in order to be able to find these things. So we have to have the mean, the median, the mode, and the range for this information. So I know that in order to find the median, I have to put them in order. So I'm going to start by putting my data in order. I see that my smallest number is an 8, and I like to just mark them out so I know that I use them. And then next, I have a 22. I have another 22. And it looks like I have another 22. And then the next piece of data that I see is a 24. And then I see a 26. And then I see a 28. Actually, I see a couple of those, so let's write all of those down. And now I see a 30. Actually, there's 2 of those. Oh, there's actually 3. So there's my 30s, and then I see a 33, a 33, a 33, and there were lots of 33s, weren't there? And now I see a 38 and a 40. Did I skip a piece of data? 1, 2, 3, 4. I sure did. Do you see that guy sticking out right there? We have to be really careful. So let's just squeeze him in right there, and we've got him done. Got to be really careful. Okay, so now we're going to use this to find some information. I'm going to start with the median since I already have it there. And I am going to do this. So it can't be this or this. It can't be this one or this one over here. It can't be this 22 or that tiny little 33 that I almost forgot. Can't be this 22 or this 33. Can't be this 24 or this 33. No 26, no 33. No 28, no 33. No 28, no 30. No 28, no 30. So it would appear that my median number of cars is 30 cars. Okay, now let's work on the mean. So we're going to add all of these up. We're going to use that quick little shortcut that I showed you earlier. So we're going to add 8 plus, and then we're going to open parentheses. We have 22, and we had 1, 2, 3 of those, so 22 times 3. Close your parentheses. Plus a 24 and a 26. We don't need parentheses for those. Next is 28. I had 3 of those, so we're going to open. Oh, I forgot my plus sign. Plus, open parentheses, 28, and we had 3 of those, close parentheses, plus 1, 2, 3 of those 30s, so 3 times 30. Make sure you're using your parentheses, plus 1, 2, 3, 4, and then the almost forgotten 5th 33, so 33 times 5, plus I have a 38. And I have a 40. So all of those together is 541. Let's see how many home games there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it looks like there were 19 games, so we're going to divide that by 19. And we get 28.47, blah, blah, blah. And we all know that that's not really useful to us, so I usually like to round it off to 1 decimal place, so that would be about 28.5. And we all know you can't have half of a car, right? We did talk about that earlier in class, but this is a description of the data, so if that bugs you, you could say it's between 28 and 29 cars on any given day. The mode is next. The mode is the one that appears the most, and I do believe that 33 is the winner there. It appears 5 times. And then the range of cars is how far is it from 8 to 40? So 40 minus 8 is what we're working on there. That would tell me the range of 32. Now, this is a neat question. It says, what is the distribution of the data? Remember that in a perfect graph, the median and the mean would be in the middle. So if you think about this, my median is 30. So if you just very quickly sketched a graph that looked like this and put 30 in the center, and then you thought, okay, well, my biggest number is 40, so it's going to be somewhere like this. But my smallest number is going to be way down here at an 8. This shows me that my graph is probably going to look something like this, because this one is stretched way out from this middle number. So it says, what is the distribution of the data? Well, we've talked about a distribution that looks like this. Remember, we said the center of the graph is here, and this is a tail that is very long, and if we have a long tail on the left side of our graph, then this is called a skewed left data. So it's left skewed or skewed left. Then it says, does there appear to be an outlier? And a lot of students might choose this 40 because it's big, but remember, an outlier can be small. And if you look at all of your data, a lot of the data was in the 20s and 30s. But we have this one day, maybe it was raining and no one wanted to come to the basketball or the baseball game. Maybe it just wasn't a very good team and they didn't want to come and watch the game. But regardless, this one doesn't really fit with the rest of the data. So yes, I would say that there is an outlier, and the outlier is that in that one game there were only 8 cars. So I want us to summarize what we've learned today in this little chart at the bottom, and it says, what does this mean for us? No pun intended, not about the mean or the average, but what does this tell us about a set of data? So the mean, remember, is a fancy word for the average, if you want to write that in your chart. The median is the fancy word for the middle, and the mode is the fancy word for the most or the most often, however you want to write that in. So it says the mean is best used. So think for just a second to yourself, when is the mean the best choice to use for your data? And I hope that you figured out the mean is best used when there are no outliers. Because we've talked a lot about how an outlier changes your average. Think about your grades. Remember, we talked about that example in class. If you normally make 90s and then you mess up one day and you make a 50 on a test, your grade is going to drop, your overall average. If you are a basketball player and your free throws are usually in the teens, and one particular game you get fouled a lot and you make 30 free throws, then your free throw average is going to skyrocket because it's going to change your average. So when you have outliers, it really changes your data. The next one says the median is best used when you have an outlier. So the average or the mean is best used when there are no outliers. The middle number, the median, is the best description when there are outliers, because the middle is exactly in the middle of the data. So that's going to be a better representation of the bulk or the cluster of your data. The mode is an interesting one. Honestly, the mode is most useful, is best used when you have categorical data. And so we're talking about like if you ask, what's your favorite color, or what's your favorite pizza topping, or what's your favorite type of music. You're not going to have any numerical data with that, so you're not going to be able to find an average, or you're not going to be able to find a mode, not a mode, but a median. Instead, you can use the mode to give you a description of what most of the people said. So mode is best used when you have categories of information instead of numbers. So feel free to go back and watch any of the videos that you need. The instructions on your page tell you where to put this into your notebook, and then you may move on. Thanks.